Welcome everyone to Heating in Industry. In previous videos, we have mentioned the importance of reducing carbon consumption and emissions in the industry. In the series of lectures on Module 3, Heat Systems, the major heat transfer mechanisms, integration, management technologies, and sectors were described. In this video, we are going to talk about the importance of energy and particularly heat requirements and energy efficiency in the industry. Utilities are ancillary services needed in the operation of any production process. They can be fluids for process heating or cooling, like steam or cooling water, also fuel, process water, air, or other gas supplies that are inlet streams to the conversion process and or to the auxiliary units, and of course, electricity. Today, we focus on the requirement of fluids that provide the needed heating and or cooling services for a particular process to be executed. Keep in mind that the heating source tends to be a combustible fuel, such as natural gas. Since industrial processes tend to be located in industrial clusters, heating and cooling are taken for granted. And don't get it wrong, this is the whole purpose of being located in clusters, to share resources. Keep in mind that heat generation, as electricity generation, needs to be sustainable. Heating needs are very important. The figure represents the European heating and cooling needs per sector, industry, services, and buildings, in terawatt hours for a year. Red and blue colors represent the heating and cooling needs. Note that the consumption for heating and cooling is dominant in the residential, tertiary, and industry sectors. The heating and cooling sector is characterized by low efficiencies, large amounts of waste heat, defined as the amount of heat that is not used and that needs to be evacuated, for instance, with a cooling stream. And it is mostly fossil-based, as mentioned before. Remember these figures. Heat represents roughly 75% of industrial energy demand, and this corresponds to approximately 33% of CO2 emissions. We mentioned before the importance of improving the energy efficiency. This can be done as soon as possible with current processes, since this does not depend on the source of heat, which has to be greenified. To achieve deep emission reductions in the heating sector, synergies and interactions among the different energy carriers and energy uses are encouraged. For example, integrating heat generated in industry with heating needs in the residential sector. This is called sector coupling. Sector coupling and or integrated system approach, which means a stronger integration of electricity, gas, heating, cooling, mobility systems, and markets to maximize synergies among technical solutions, has to be encouraged. In the figure, we see a cascading effect. High temperature waste heat can be integrated with lower temperature heat needs, not only within the boundaries of a specific industrial process, but also, remember, sector coupling is possible. What happens if the industrial process changes? What happens if a new or alternative process replaces a traditional fossil-based process? Heating needs will change, and possibly one well-integrated solution that you have worked on is not valid anymore. Therefore, in order to improve heat efficiency today, it is important to focus on parts of the industrial process that may not change if other changes are in place, for example. It is therefore important to appropriately reflect and design the transition. Let's zoom in two aspects mentioned before: waste heat and heat integration within the boundaries of an industrial process. The second one is represented in this figure as internal energy use. External integration may represent sector coupling or integration with other industrial processes. The circular flow represents waste heat used within the process, avoiding the use of raw fuel. Non-usable heat is defined as the heat that cannot be further used because of a very low temperature level or because two streams cannot be heat integrated because they are too far away in the space, or because you want to avoid a leakage in a heat exchanger between a combustible stream and air, for example. Industrial heat is currently mainly generated via the combustion of natural gas in traditional and highly efficient boilers, energy efficiency above 90%. Water is usually heated up with the heat released in the combustion and used as a heating fluid. Highly efficient and flexible new technologies must be implemented and developed, implemented in existing or new process and connected to the electricity grid that is also under development. The future of industrial heat will depend heavily on electrification, require a major shift to renewable electricity. This transition demands tight coordination between industries, energy systems, and the power grid. Overall, the principle that needs to be followed in heat management in the process industry is doing more with less, which applies the principles discussed before on heat integration and decreasing the use of raw fuels. This slide summarizes the transformation of the process industry as a whole, including alternative processes to synthesize sustainable products and alternative technologies that produce heat. Given the crucial role of heat in both conventional and future sustainable production processes, new methods for generating, storing, and managing heat are to be developed and implemented. As a summary, heating needs in the process industry are significant, and both electricity and heat generation have to be defossilized. It's not just about new technology. Success will require a holistic approach that integrates technical, economic, and societal factors. Ultimately, heat management also deals with the same principles applied to any renewable process: management of intermittency and generation demand match. Not only alternative sources, but also better efficiency, reuse, and decreased consumption are principles to be followed when thinking on the heating needs and network of the future. Thank you very much for your attention.